Bismillahirrahmanirrahim. Assalamualaikum to all of you. My name is Ariza binti Zainal. I'm from UTHM, Malaysia, and my partner is.
My name is Muhammad Al-Amin bin Abdul Rahim. I'm a student from UMK Al-Tech. Today I want to present about our project. The title is Intelligent Water Level Monitoring and Control for Rainwater Harvesting using IoT.
Rainwater harvesting system is an advanced solution and system that implement modern technologies like automation, renewable energy system and the Internet of Things. The rapid urbanization in Malaysia has led to an increase in water demand and challenges in managing water resources. Therefore, the existence of the rainwater harvesting system is very necessary to overcome these issues. This is our problem statement. The manual rainwater harvesting faced some problems such as insufficient water collection, wasteful water uses, and the lack of real-time monitoring that can lead to overflow.
The development of a sustainable rainwater harvesting system with real-time monitoring and automated control for urban Malaysia has several components to optimize water collection, storage, and management. The system consists of a rainwater catchment unit, a basic filtration and storage unit, and a control and monitoring system. The catchment unit gathers rainfall through a basic filter before stored in storage tank. The entire system is established by IoT technology to enable real-time monitoring and control of water levels and also water flow.
Our objective is to develop an efficient and sustainable rainwater harvesting system tailored for urban areas in Malaysia. And the second one is to control and monitor the water level in the rainwater storage tanks and automate the opening and closing of the valve based on the water level set point. The variable is an incoming rainwater flow rate, and a control variable is the water level storage tank, and the manipulate variable is the control valve.
The main control parameters in the system are the water level in the storage tank and the water flow rate. To reach optimal storage utilization, the implementation of sensor is necessary to continuously monitor the water level, while the flow rate sensor measures the movement of water through the system. This measurable and reading from both sensors are transferred to the control system, which is to give instruction for actuator action to manage water flow and ensure efficient collection, distribution, and prevention of overflow. Moreover, the manipulate variable in the system are the operation of the valve, water pumps, and flow control mechanism. The system adjusts these components to control water level, and water flow depends on the data from sensor. For example, solenoid valve will be open or closed based on data provided by ultrasonic sensor, which detect water level is full or not. The system operates as a closed-loop control system which has sensor feedback that affect actuator action continuously. The methodology of our project follows a smart and automated sequence for managing rainwater flow. Rainwater first flows from the gutter into a connected piping system. If the catchment area reaches its capacity, the solenoid valve 1 is activated to divert excess water directly to the drain tank to preventing overflow. Then, if the catchment area is not full, the system continues to monitor and log water flow data while directing water into the storage tank. Once the storage tank reaches its maximum level, the solenoid valve is automatically closed and the user is notified via the Blink application. Upon launching the Blink app, a connection is established with the IoT-enabled controller. User can set a custom water level threshold based on their needs. If the water level falls below the set point, the solenoid valve will open to allow more water into the tank. If the level exceeds the set threshold, the valve remains closed to prevent overflow, ensuring efficient and safe water management. As you can see, this is our prototype, and you can see that we are using ESP32 as a controller, solenoid valve as an actuator, and Blink apps as a software in this project. As rainwater flows from the gutter into the pipe, a portion is directed into a storage tank. When the tank reaches full capacity, the excess water is automatically diverted into the drain. The system integrates with the Blink app, which collects real-time data on water volume and flow rate, enabling users to monitor and analyze the system performance effectively. To enhance control, a manual hand valve has been modified into an automated valve system. While commercial automatic valves are available on the market, they are typically expensive. To offer a more affordable alternative, we utilize an ASNG MTB 360-degree servo motor steering motor coupled with a gear mechanism to rotate a standard PVC ball valve. This setup allows precise control of the valve's opening and closing percentage via the Blink app, providing greater flexibility and responsiveness in managing water flow. This is the side view of the actual system, comprising a storage tank, solenoid valve, water inlet, drain valve, and a controller unit for system automation and monitoring. These innovations contribute to sustainable water resource management, particularly in urban and water-scarce areas. It promotes the reuse of natural resources, reduce dependency on treated municipal water for non-potable uses, such as for toilet flushing and irrigation, and also support climate-resilient infrastructure. Additionally, the low-cost automation approach makes it more accessible and scalable, particularly for residential and institutional application, thus amplifying its potential environmental and socio-economic impact. So, this project is an innovative solution that integrates sensors and smart valves to enable real-time monitoring and precise control of water level. This system not only ensures efficient collection and storage of rainwater, but also minimizes water wastage through intelligent overflow management. Thank you very much.